Hello and welcome to my road test of the Rohde Schwarz RTM3004 oscilloscope. Thank you to Element 14 and to Rohde Schwarz for supplying this to me to a road test. They sent me this device, so full disclosure there, but they've not asked me to do anything other than give an honest opinion of it. So that's what I'm going to do. So let's take a look at the device. First of all, first thing you'll notice is the 10.1 inch screen. One of the main features of the device. It is quite shiny. You can actually see me reflected in the screen there, hello. But we'll see later on in use whether that is actually an issue or not. There's a nice uncluttered front panel here, partly because there's just one set of vertical controls for the 4 inputs and also the other inputs, which I'll cover later. You'll notice there's no buttons around the screen either. That gives it a nice clean look. This particular model is a 4-channel. There's also an RTM3002 version, which is just 2 channels. Also, there's a lot of options that comes with this scope. It comes in everything from 100 megahertz up to 1 gigahertz, and everything apart from whether you've chosen 2 or 4 channels is upgradable later via software. So on the front, you'll find a USB input that's useful for things like taking screenshots, upgrading firmware. There's a pattern and function generator, which I'll come to later, and an external trigger, and then the 4 main channels here. You'll notice they have pads underneath for the Rohde Schwarz probe connector. This is useful if you're adding things like active probes that need power and can communicate with the scope other than just the channel input. Right, so moving around the device. Around this side you'll find these 2 inputs here for the digital logic pods. They use a HDMI-B connector, which is quite unusual. Apparently it was designed for if you ever use 2 HDMI monitors on your PC. I'm not sure that ever actually happened, but they're the connectors you'll find there. So there's 2 8-bit pods. If you got one, if you just need 8 bits of digital input, you use 1 pod. 16, you use 2. Continuing around the back, there's a trigger output, a USB connector to connect to your PC, and also gigabit LAN. I'm glad to see there's actually a proper power switch here. I don't like devices with just a soft switch. You're never really sure whether they're powered off unless you pull the plug out the wall. And some devices draw a surprising amount of power when they're actually plugged in on a standby. This has a nice proper power switch. There's also this very interesting little cover here. Unfortunately, I have to disappoint you and say there's nothing under there, and also nothing I can see that's going to be under there either. This shares the same case with the RTB2004 oscilloscope, and also I assume some other devices that are going to use this. But yeah, nothing interesting under there, I'm afraid. So that's the main view of the scope. You also get with it a set of either 2 or 4 probes here. They're 500 megahertz passive probes. They're very nice. They're 10-to-1 fixed rather than switchable. The quality is very good. Even down to things like the alligator clip here. You'll see this has got a nice fine teeth. I found it really grips nicely on things without actually shorting out. If I compare that to a typical clip from another scope, you'll see much finer teeth, just much nicer. It's these little things I found on the scope that make quite a difference. You know, you may think this is not important, but actually in use, it really is. So there's a standard sprung hook here, which you're all familiar with, and underneath you'll find quite a sharp sprung pogo pin tip. Now, I know not everyone is a fan of those. I find it works quite well. So along with the probe you get this pack here. The thing in blue here looks like a fuse, is actually just a solid tip if you would rather replace the sprung tip with a solid one. You get all the usual bits and pieces. There's a ground spring, a trimmer for adjusting the compensation, little plastic rings, the usual stuff. This particular model has the 16 channel logic analyzer upgrade as well. So connect this, you get 2 of these flexible cables, obviously one for each 8-bit pod, with the HDMI-B connector on here, and it actually uses coax ribbon cable, which I've never seen before, but I'm guessing that as this is now 400 megahertz compared to the RTB2004's 250 megahertz digital channels, that it needed ribbon cable. These connect obviously to these little pods here, Once again, a bit of an upgrade over the previous RTB 2000 series. So if you've got a 16 channel logic analyzer, you have 2 of these pods and 16 of this setup here, which actually connects to your circuit. So look at these in detail. You've got the connector, you've got a ground connector as well. These fit quite nicely onto standard pin headers, or you can attach these grabbers here. If you need be, you can actually connect your ground via that as well. So all in all, it's quite a nice setup. These are quite nice little grabbers here, quite a fine pitch. I found they work very well. Basically everything I found about the scope, the quality of everything is really good. Finally, the last thing you get is this little pouch here. Apparently, according to the manual, you can put probes and things in. I find that would be a bit, I'd be worried about flexing the leads too much on the probes here. I wouldn't use it for probes. I would, however, use it for sticking the logic analyzer pod in and things like that. But generally it's for useful bits and pieces. And there you go. That's the device in its off state. Now let's get a little bit more interesting and switch it on. Okay, so you can see that powering up is reasonably quick. I've done a full comparison between this and other scopes, and the first thing you see is that lovely bright screen. Most of the settings are remembered. The only one that hasn't remembered is the fact that I had the signal generator on. And there you go. It doesn't take long to be up and displaying traces. So the main feature here is this really nice screen. 10.1 inches. It's lovely to use. You'll see here, because it's got quite a large screen, quite high resolution, there's some nice annotations on here. The time since trigger, and also for each channel you select, it will actually display the voltage here. A nice feature. It's not that hard to work out what the voltage is, but it's nice to have it displayed on screen for you. Down here you'll see the settings for each probe. Channel 1 I've actually set to, it's gone straight here, I've actually chosen 50 ohm input impedance, and obviously a 1-to-1, 100 millivolts per division. You'll see that nice little red arrow there. That's showing me something which perhaps you'll miss on a transient, which is the fact that I've actually, the peaks here are going off the screen. So let's move that down a little. There we go. Now we realise that actually this is the peak here. It was a little bit off the screen. Perhaps rarely obvious on this waveform, but sometimes with a sharp peak you might not notice that. Using the controls here, you can see that the same vertical controls. At the moment it's yellow, so that's showing you I'm adjusting channel 1. If I press channel 2, this goes green, shows me that I'm now mucking around with channel 2. Quite a nice feature I found is that, let's say you've got this is way out. A lot of scopes, obviously you've got the functionality to auto set all the settings. But on here, let's say I've actually got channel 1 exactly where I want it. So channel 2, I'll actually just auto scale channel 2 on its own, which I think is quite a nice feature, which I haven't seen on any other scopes that I've used. So the probe interface here, you'll notice that channel 1 is currently set to be a 50 ohm input and 1-to-1, which is shown over here. Let's say I'm actually not going to bother with that anymore, and I just want to use the probe on channel 1. So if I move that over, you'll see immediately that the probe will switch from 50 ohm to 1 mega ohm input impedance, and also the scale goes to the scale's gone down to 10-to-1. So obviously this is done using the little pin here on the probe, which tells the scope exactly what it is. If you've got something like an active probe, that will do more than that. It will obviously switch. Let's say it's a current probe, it'll switch it to showing current rather than voltage. One of the most impressive features of this scope, I find, mainly because of the large screen, is the zoom feature. This is a thing I use a lot, and I find this is probably the one standout feature. So you click zoom, and you go, you know what, I'm interested in details of this this waveform here, and there you go. You've now got it shown on the lower part of the screen. Notice how I can actually scale and zoom this independently of the top trace. I can see now this detail here. Let's switch it to single. I can see the detail and the noise on this square wave down here, but without losing the context up here. That's what I find probably the most important. I can scale this independently, both horizontally and vertically. I can scroll using the on-screen controls or my fingers. Let's go over here, and that's what I'm interested in. So you'll notice the top trace, I'm not changing scale, and the bottom trace I am. And there we go, we can see a very slight amount of overshoot and noise on that square wave, but we can see the context up at the top. The touchscreen is great. That's one of the main features here. I find you've got lots of options for what you're doing. You can obviously move traces and things with the standard controls, but let's say I enable all the controls here, channel 3 and channel 4, no input on there. Let's also set those. There we go. So if I want to move channel 4, I can either use the controls here, or I can use the touchscreen to do it. One particularly nice feature, let's say I do this, and it's not sure which one I want to use. Is it channel 1, 3 or 4? Both of those are in the same place. I can say, you know, I'm actually want to move channel 3, and then I can drag it down. Obviously this doesn't replace the standard controls you'll be used to here, but it's a nice addition. So the usability of the touchscreen is probably one of the main features of the scope. Something I'll cover a bit more in depth in my review, but it's nice that the options are there. So some of the standout features of this scope are the 10-bit ADC and also the very large memory depth. I've gone into these features in detail individually in my written review, but I thought I'd try and show you some of them all together in this overview video. So you have 80 mega samples available in a single event if you're using just one channel, or maybe channel 1 and 3 together, or 2 and 4 together. As soon as you need to use 3 or more channels, or if you start using the logic analyzer like I'm doing now, then this drops down to a still very respectable 40 mega samples. So one of my previous projects was this NFC reader here to read the NFC chip embedded in my hand. It uses some SPI communication between the microcontroller and a TRF7970A NFC reader, and as part of this, the whole fire up the NFC reader, get it scanning for NFC tags, wait a while, if one is not detected then shut it down, takes a very long, in a microcontroller sense of the word, 200 milliseconds. So to test out the memory depth, I've tried to capture this whole process. So you see here I've set this to 20 milliseconds per division, so it gives a whole 240 milliseconds across the whole thing, and it's recording the whole NFC waveform, as you can see here, at 13.56 megahertz. And I've actually managed to do this with the whole memory depth. I'm actually triggering on the digital channels. I'm actually triggering, if you notice here, the trigger is set to serial bus, and I'm triggering on a 16-bit pattern in the SPI channel. So I'm waiting for the command 0020, which is the SPI command to say switch on the NFC reader, and I'm managing to capture the whole 240 milliseconds here and yet trigger on that sort of detail. So if I zoom in, you'll see it's actually decoding 0020 here, which is the command after a little bit of a delay to actually fire up the NFC reader. And this really wouldn't be possible, and it's not possible in other scopes without this sort of memory depth. As soon as you start saying, well, actually, I need a whole 220 millisecond trace, you start losing the detail, you start losing the ability to capture a 4 megahertz SPI signal in detail. Now obviously if you wind up the time base, you know, a lot of scopes can do this, but what they can't do is that in the context of the larger picture. A little bit of good try for example in this case, because I could obviously trigger off the SPI and look at the analog signal independently, but I really was interested in finding out whether the mix signal abilities of the scope, the ability to mix analog and also the digital channels, was useful. And it was. When I prototyped this device, I used a separate logic analyzer and oscilloscope, and it worked, but I kind of saw the two things independently. But here with this memory depth, you really can see that it's captured the whole thing. And also the 8-bit ADC, which I think was showing very well zooming in earlier, I can still zoom on this signal here, and without recapturing with a see it's set to 2 volts per division, you can actually see all the detail in this signal is captured well. There we go, there's my 13.56 megahertz NFC signal. The 10-bit ADC has captured the whole trace nicely. The features available for the logic analyzer and protocol decoding are quite extensive. There's quite a few buses you can do. There's parallel buses, which don't seem as feature rich, to be honest, as the serial buses. There's the usual configuration of SPI, I2C, UART, CAN, LIN. There's audio, and then some military ones here, which I must admit I'm not familiar with. All these available as options. Unfortunately available to purchase separately. So if you do need all of these, it can add up. But it's nicely configured. You can see here the protocol analyzer can work on not just the digital channels, but also any of the standard oscilloscope channels as well. Lots of configuration. This particular NFC reader uses a falling clock for SPI, which I found on my my Rigol 1074Z, a scope many of you be familiar with. I just couldn't decode on that at all. The triggering is very nice as well. You can trigger in SPI, for example, on frame start, frame end. Serial pattern is quite useful. So here, obviously, that's the command I was waiting for. And the triggering is nice, as you can see, works very well, even with quite a long time base. The scope's got some very unusual but some quite nice features, one of which is power analysis. Here you can see I've got a DC to DC converter taking 16 volts in and giving 3.3 volts out. There's a lot of power analysis functionality built in here, which is great, especially it's built at doing switch mode power supplies. But I thought really the output, the ripple and transient response, I thought really would apply just as well to something like a DC-DC converter. So for instance, here I'm going to measure the ripple. It says it's expecting you to be using a differential probe. But I thought, to be honest, that using the standard probe here would be fine on an isolated DC-DC converter. I can quite happily measure the voltage output. So I thought I'd be able to measure the ripple. So let's start this and find out. So here we are. It is at the moment measuring the input. So I've got about 16 volts going in. That seems to be okay. And I can also measure the ripple on the output quite easily. Lots of nice measurements here, just sort of thing you want to be measuring, but rather than doing it yourself, it's quite nice. It does it for you. It will also output these quite nicely. Once again, in the written report, I've got a bit more detail. Output this nicely as XML, and you can then on the PC import it in and print it out in a nice format if you're doing a report. One thing I found didn't work quite so well, and I got a bit stuck, was when I tried to measure the transient response. It doesn't really say, so it's not very clear, but I think if you're not using a differential voltage probe, things start getting a bit weird. I couldn't really seem to get it working. If I try and set the top and base level, try and set the voltage, I get these little flashes of it's popping up. I get measurements moving randomly all over the screen. To be honest, I think the problem is that I've not got a differential voltage probe, but it doesn't really say anywhere other than just one line in the manual that this might be a problem. I should be able to measure transient response on a DC-DC converter with the supplied probes, but things just start going very strange when I try. This is probably the only place where I found the usability of the scope is a little off. If it said perhaps you're not using one of the approved probes, then that'd be fine. But there's nowhere it does that. It just sort of starts behaving oddly. So unfortunately, I couldn't check out all these nice features. If you're designing power supplies, then I'm sure these are going to be real. Unfortunately, I'm not, so I can't really dig in too much into this. One of the standard features of the scope is FFT functionality. Here I've got a nice sub-gigahertz microcontroller board outputting, which scanning from 800 to 900 megahertz. So if I switch to FFT mode, you can see quite a nice display here with it stepping through. It's got all the usual FFT functionality. You can change the windowing from flat top to Hamming, Hanning, Blackman. Change the source. You can only analyze one channel at a time. Let's switch on max hold as well. You can see it scanning through the various frequencies. Works very nicely, I find. There is a spectrum analyzer add-in which extends the FFT functionality, but unfortunately this wasn't available in time for me to do this road test. But to be honest, the FFT functionality is better than I've seen on any other scope, and it's starting to get close to Spectrum Analyzer. I can't be sure, but I suspect that unless you have the 1 gigahertz bandwidth upgrade, you won't be able to use 1 gigahertz for spectrum analysis. If you look here, this is set to the full span, which is from 0 to 1.2 gigahertz. I found a few quirks in here. On an earlier version of the firmware, I did manage to find that it could let you set the start to be below, to be negative hertz, and you've just got an unused bit of space. Even now, I find here the start frequency, I can set it to be maximum of 2.15 gigahertz. I've occasionally seen 2.3 in there. It doesn't actually work if you try it. Set it to 1 gigahertz. There's some oddities. So 1.8 here. So I've now got from 815 to 1.6 gigahertz. I've not got a reliable source to see if that's actually, if it does work up to 1.6 gigahertz. I'm not sure. If you do full span, that's 0 to 1.2. So I suspect that's a glitch in the software rather than actually a feature. You can go up that high. If I show you a little bit more, so I start at 800 megahertz. I'll stop at 900. You can see a closer view. Low limit reach. See, there's some oddities here. It doesn't seem to behave quite how you'd expect. So let's set the center to be 850 megahertz, and my span to be, yeah, say 400. That seems to be working fine, but it does seem to be possible to introduce some glitches into the UI on the FFT functionality. But generally, it works well. You can see here, you can see it scanning. I set it to scan from between 800 and 900 and 10 megahertz steps. Get quite a nice output. The spectrum analyzer functionality is looking in the manual. Obviously, I can't test it out. It does seem to be more of an add-in, extra features for the FFT stuff. It's not a true swept analyzer. It just works on the waveform up here, but fairly impressive. I do like it. It's a way above the sort of FFT functionality I've found on other scopes, and it works pretty well, other than the software glitches. And to be honest, Rohde & Schwarz seem to be quite good at sorting out these sort of glitches. They fix any problems quite quickly. I wouldn't be surprised, give it a month or so, if these have been sorted. So there are a couple of ways to control the RTM3004 remotely. One is obviously over USB, which I've described in my my written write-up, but probably the best one is over Ethernet. Now you find out why there's a gigabit Ethernet port on the back. So here's the opening screen. Once you've given your device a name, you just go straight to it, and here you go, basic information. It's a page for taking screenshots. I don't know why this is rather slow to load. Everything else seems quite fast, and there's just a couple of buttons here for a few functions. Scpi device control supports everything that the device supports. Here you can save and load display data, all the recorded waveforms, every setting. So basically everything you can do on the device you can also do via Ethernet. Page for the network settings. All I've really done here is change the host name, which ends up being up here, the actual URL that you go to. You can change password. Live screen, very useful. Simply displays the screen of the device. It will scale, so if I uncheck auto scale, this is native resolution, you can see quite clearly. For smaller screens, obviously, you can scale it down. Very useful, I can imagine, if you're trying to demonstrate something in a classroom. And last but not least, the remote front panel. Once again, if I uncheck auto scale, you see nice and clearly the resolution that will come across. But just for ease of use, I'm going to scale it down here. So basically, you've got your live screen as you had normally, but you've also got all the same controls on the front panel. You can click them, rotate them over, the same way you normally would. So, for instance, if I take channel 1 and I decide I'm going to change the vertical resolution, I can. I can click, I can rotate, perhaps not as easily as on the actual device, but it all works. I can, for instance, so here you can see I'm triggering on the decoded waveform, and let's say, and the analog channels are out of sync. Let's say I want to change trigger. So I'm currently triggering on serial bus. So I want to edge trigger on channel 1. There you go. Everything you can do by pressing buttons on the scope, you can now do here, and you can now see that the serial bus is out of sync with the top waveforms. You can go through any of the functionalities here. You can turn on and off the function and pattern generators. Basically everything you can do via the front panel. So nice and simple, but very useful. There you go. Probably the easiest and most obvious way to control your scope over the network. And I suppose it's time for a summary, really. So summing up, the RTM3004 is an amazing oscilloscope. The features are great, the usability is great. The few minor glitches that I've come across, I'm sure can be sorted out in firmware. Some maybe user error. It's all round very impressive, and not just the things you can see in the spec sheet, but the really small things, the things that just add to day-to-day usability. The only downside, say, is it is expensive. Not just the base scope, which you kind of expect, but just all the bits and pieces, the individual decodes, the fact that you can't buy 8 channels of logic analyzer, you have to buy all 16, and all the accessories are very expensive. Even like spare bits for your probes, I found were very expensive. So it is amazing. If your boss is buying it for you, I'd say definitely go for it. I find it hard to justify spending my own money on it, but on the other hand, now I have one, I definitely can't see myself going back to a more budget scope. This is definitely not going on eBay. I'm hanging on to this. I'm a bit spoilt now with all the features and functionality. So yeah, I can't really fault it other than the odd glitches, and you'll know yourself whether you think the price is worth it for what you'll get out of it. But all in all, I say I can't really recommend it highly enough. It's an incredible scope, and thanks again to Element 14 and Rohde Schwarz for giving me the chance to review this. Thank you.